A and B are such that the probability of A is 0.4, probability of B is 0.9. It says the probability of A and B is 0.6. State given reason whether A and B are independent. Are they independent? Well, two events are independent if the probability of A and B is the same as the probability of A times the probability of B. Now the probability of A times the probability of B, we know that that is going to be equal to 0.4 multiplied by the probability of B, which is 0.9. And when we multiply 0.4 times 0.9, we get 0.36. Now 0.36 is not equal to the probability of A intersect B, because it told us that the probability of A intersect B, this was 0.6. And so clearly it's not independent. So A and B are not independent. A and B are not independent. Nice. Now, part B, are they mutually exclusive? Two events are mutually exclusive if the probability of A union B is equal to the probability of A plus the probability of B. That's when two events are mutually exclusive. Now, let's look at it now. The probability, well, no, it's not mutually exclusive because the probability of A intersect B should be 0. But the probability of A intersect B from this right here is 0.6. Since the probability of A intersect B is 0.6, which is not equal to 0, and so they are not mutually exclusive. Nice, so they are not mutually exclusive. Easy. So they are not mutually exclusive. Easy question. So since as though they're not mutually exclusive, we're nice. Easy. This says Ian travels to school either by bus or taxi or a private car. The probability that he travels by bus is 0.2. It's always good to write it down. The probability that he travels by bus is equal to 0.2. They tell us also that the probability that he travels by taxi is 0.3. And then the probability he travels by a private car, let's use private car as private car. Let's use C, travel by private car. All right, private car. All right, let's use PC, private car, P with a subscript C, private car. It tells us that that's 0.5. Then it tells us what now? It tells us the probability that he arrives on time if, that means given, the probability that he arrives on time given he travels by bus. So given that he travels by bus, the probability he arrives on time is 0.6. Then they tell us now, and if he travels by taxi, then the probability he arrives on time, given that he travels time, let me call time. Since taxi, I can't use T for time and T for taxi. Let's use T1 for time. T1 is for time and T is for taxi. The probability he arrives on time, given that he travels by taxi, it says that is that's 0.6 was for bus, 0.9 for taxi, 0.9. And then for private car, the probability he arrives on time, given that he travels by private car, which is PC, is equal to 0.8. And they want us to represent all of this on a tree diagram. To represent all of this on a tree diagram, let us fit it right here, of course. All right. I want to fit it on time on a tree diagram. Let me see. Let's do it. We don't have enough space right here. So 0.2, 0.3, 0.5. So we're gonna go to the whiteboard right here. All right, let's do it on the whiteboard. And so first is, what are the different ways you can go to school? You can go to school either by taxi, either by bus, or by a private car. So this is the three of them. So this one to represent taxi, and this one to represent bus, and this one to represent private car. Probability of him traveling by bus, I think that one was 0.2 for bus. For bus, that one was 0.2. For taxi was 0.3. And then for private car was 0.5. Nice. Then now it says, now what's the probability he arrives on time? Is either him arrive late or him arrive on time. So since him take the taxi, what's the probability he arrive late? And what's the probability he arrives on time? All right. The probability that he arrives on time, remember I'm calling T1 time. All right. And I'm calling, let's call late L. Either him arrive on time or him arrive late. Given that him take a taxi, the probability of him arriving on time, given him take a taxi, was 0.9. So there's every chance that once him take a taxi, him arrive on time. This was 0.9. That means the chance of him being late is 0.1. Then it want now the probability of him taking a bus and arriving on time. That's T1. I'm calling it T1 and this is L. L for late. So the probability of him arriving on time, given that him take a bus, is 0.6. That's 0.6. So chance of him arriving on time is 0.6. Chance of him being late is 0.4. Now if him take a private car, chances of him being early is, let's look back at it again. If him take a private car, chance of him being early is 0.8. And chance of him being late is 0.2. This is 0.8, and then this is 0.2. So let's need to, that's our tree diagram. This is it. That's the tree diagram for Ian. Tree diagram. Nice and easy, soft. Now let's hear the question. The question went on to say, find the probability that Ian does not arrive on time. So you want us to find the probability Ian arrives late. So find the probability that Ian arrives late. The probability of Ian arriving late is going to be all of these. It's going to be the probability him take a private car and still reach late, the probability him take a bus and still reach late, and the probability him take a taxi and still reach late. So the probability of him being late is going to be equal to the probability him take a taxi and still be late, plus the probability him take a taxi and still be late, plus the probability him take a bus and still be late, plus the probability of him taking a private car and still be late. That's all working out. Nice and easy, soft. So to find what all of this equal to, that's going to be equal to now, the probability him take a taxi and still be late is going to be equal to probability him take the taxi, which is 0.3, times the probability him be late when taking the taxi, which is 0.1, plus The probability of taking a bus and late is the probability of taking the bus times the probability of being late when taking the bus, which is 0.4, plus the probability of taking a private car is 0.5 times the probability of being late when taking a private car, which is 0.2. We work those out. So when we finally work these out, what we're going to get is 0.21. That's going to be the probability of them being late. 0.21, nice and easy, soft. That's overall the probability of him being late, 0.21. Nice and easy, soft. And we did that using the tree diagram. Easy question, soft. All right, so just to write it down right here, part B, probability of him being late, as we saw from our tree diagram, was 0.21. Nice. Here it says, the events x and y are such that the probability of x given y is equal to 0.8, and the probability of y given x is 0.5. The probability of x intersect y is 0.24. Find the probability of y. Well, since this is a conditional probability, and we have the probability of x given y is the probability of x intersect y over the probability of y. So write that down. Probability of x given y, this is, by the way, is a x, probability of x given y. We know that is equal to the probability of x intersect y over the probability of y. So what does that mean for us? What that then means for us is, look at this right here. The probability of x given y, it says that is 0.8. Probability of x given y is 0.8. So replace this with 0.8. Okay, that's equal to the probability of x intersect y, which it told us is 0.24. So we just need to put that right there. It is 0.24. And then that is being divided by, the probability of y, 0.24 over the probability of y. So all we're going to do is transpose for the probability of y. So let us transpose. So transposing the probability of y, we transpose, that implies the probability of y is equal to 0.24 divided by 0.8. 0.24 divided by 0.8. That's going to be the probability of y. So you work this out, that will give you the probability of y. 0.24 divided by 0.8, which is 0.3. Nice. So that's the probability of y, 0.3. Easy. Soft. Probability of y is 0.3. It says state given reason why x and y are not independent. So first, of course, we need to find the probability of x. So to find the probability of x, we're going to do the same thing again, but this time we're going to start by saying the probability of y given x now. Probability of y given x is equal to the probability of y intersect x, probability of y intersect x divided by the probability of x. Then what is the probability of y intersect x? The probability of y intersect x from this question is y intersect x, 0.24. The probability of y given x is 0.5. So that means 0.5 is equal to 0.24 over the probability of x. 0.24 over the probability of x. So then now all we have to do is cross multiply So what does that mean? That implies that the probability of x is equal to 0.24 over 0.5. That's the probability of x, 0.24 divided by 0.5. So that's what we do. So we work out 0.24 divided by 0.5. We get 0.48. 0.48. That's the probability of x, 0.48. Now that we get 0.48 for the probability of x and for the probability of y, 0.3, are they independent? Let us see. If they're independent, we first need to find the probability of y times the probability of x. So the probability of x multiplied by the probability of y, that would be equal to 0.48 multiplied by 0.3. That works out to be I am getting 0.144. But look at this. We get 0.144, but that's not equal to the probability of x intersect y. And so this is why they're not independent. Hence, they are not independent. Hence, they are not independent. Hence, they are not independent. Nice. Now look at the next thing. Now it says calculate the probability of x intersect y complement. So to find the probability of x intersect y complement, there are many ways to do it, but perhaps the easiest formula to use is this one. So this formula will tell us that the probability of x is equal to the probability of x is equal to the probability of x intersect, it's equal to the probability of x intersect y plus the probability of x intersect y complement. Probability of x intersect y complement. This one is the easiest right here to use. And so since we know the probability of x, and we know the probability of x was 0.48, and we already know the probability of x intersect y is what was this? 0.24, I believe. So that is equal to 0.48 plus 0.24, and that gives it a probability of x intersect y complement. And so what we end up get is that the probability of x intersect y complement will make this the subject. So we end up get the probability of x intersect y complement is equal to 0.24. Nice and easy, soft. 0.24. Soft, capital T. Nice. So that's what we get, 0.24. Nice. So just if you want to put it down, this part is 0.24. Soft. Nice.